So in today's lesson, we are going to be talking about polynomials. So we're starting chapter 5, which is all about polynomials. And in today's lesson, we're specifically talking about polynomial operations. Now, before we get into our operations, we do need to remind ourselves of a few of our exponential properties, because we're going to need to use these properties in order to be able to simplify some of our polynomials. So the first is the product of powers, which that one should be pretty familiar to us all. So if I have x to the a power and I multiply that by x to the b power, my base is going to stay the same, but we're going to add our exponents. Now, our quotient of powers is going to work very similarly. If I have x to the a divided by x to the b, again, my base is going to stay the same, but this time I'm going to subtract my exponents. Hopefully we recall, anytime I have a negative exponent, that is going to make it the reciprocal to the a power. We can also have a power of a power. So if I have x to the a all raised to the b power, in this case, we actually do multiply our powers. Sometimes we'll also have two things that are being multiplied that are being raised to a power. And we can kind of think of this like distributing. We're able to distribute that a value or that exponent value to both of the things on the inside. It also works with division. But be careful, because notice we do not have a power of addition or subtraction. So we are not allowed to think of it like distributing when I have addition or subtraction. We have to go ahead and FOIL that out. So just be careful with that. And then zero property power is anything to the zero power is going to be 1. So be careful with that, because a lot of people want to put that it's 0 and it's not. So just make sure that you're watching that one. So let's look at some examples. So it says simplify each expression. So I have 2a to the negative second times 3a cubed b squared times c to the negative second. So it says assume that no variable equals 0. Which is going to be important when we start having fractions. So let's go ahead and take care of our number portion first. So notice that we have 2 times 3, which is going to give us 6. And then we're going to have a, and we're going to have negative 2 plus 3. And then notice that our b squared and our c to the negative second don't have any common basis. So then we're just going to perform our operation. So negative 2 plus 3 gives us 1. And then we have b squared c to the negative second. Now the only thing is, when we're simplifying, we don't ever want to leave negative exponents. So remember that that negative exponent property tells us that that's going to move that c to the denominator of a fraction with a positive exponent now. So now I don't have anything that has the same base. I don't have any numbers that can be simplified. And then we don't have any negative exponents. So that would be my final answer. On our next one, we have division. So remember, with division, we're actually going to subtract now instead. So we have q to the 2 minus 7 which is going to give us q to the negative 5th, and then we have r to the 4 minus 3, which gives us r to the 1st. Again, because that q has a negative exponent, it's going to move to our denominator. All right, then lastly, we have a whole fraction here that's being raised to the 3rd power. So remember that we can raise the numerator and the denominator both to that 3rd power separately. And then, because we have multiplication in the numerator, we also need to apply that 3rd power to both of those as well. In our denominator, we can go ahead and perform that. Remember, when we have a power to another power, we're going to multiply. So we would have b to the 6th. Remember that we only add when we have two bases that we're multiplying together. So then we have negative 2 to the 3rd. So we'll have negative 2 times negative 2, which gives us a positive 4. Then we have positive 4 times another negative 2 is going to give us negative 8. And then we're going to have a. Well, 4 times 3 gives us 12. And then we have b to the 6th. So we want to make sure and check that we don't have any common bases, any numbers, or any negative exponents. And we don't, so that would be our final answer. All right, so let's go ahead and get into what is a polynomial. And it has to meet a couple of requirements. So the first is going to be that it has to have real number coefficients. The next thing is that it has to have positive non-zero integer. So remember, integer means whole number. Exponents. And then just kind of a sub thing, remember that the degree of a polynomial is going to be the highest exponent of one term. So let's go ahead and look and see if we can label some things as as polynomials or not. So it says determine whether each expression is a polynomial. If it is a polynomial, state the degree of the polynomial. So on part A, notice we have two variables, but in our definition, it never said that I only have to have one variable. So having two variables is okay as long as it meets those other requirements for both variables. So we have to have real number coefficients. So 1/4 and -8 are our coefficients. Both of those are real numbers, so we're okay. Then it says that we have to have positive integer exponents, which means that I can't have like 4.2, I can't have a negative, they have to be a whole number and they have to be positive. And so notice our exponents here are 4, 3, and 5. All of those are integers. All of those are positive. So our answer for part A is going to be yes, it is a polynomial. Now, the next thing that we're going to look for is it says that it wants us to find the degree of that polynomial. Be careful with this, because a lot of people's first instinct is to say 5. Because the x has a 5, and that's the biggest number that we have. However, on the definition that we wrote for degree, it said the biggest exponent of one term, not one variable. So remember that all of whatever's being multiplied together is one term. So 1/4 x to the 4th y cubed is one term. So if I wanted the degree of that term, I would need to multiply those two bases together. Well, we can't actually multiply x to the 4th and y cubed because they don't have the same base. However, if we were to simplify that, remember that we would take 4 plus 3 and we would get 7. So that means that our degree is going to be 7. So we just have to add together anything that's in the same term. Now, in our next one, notice that we have x's, so that's fine. Our coefficients are 1, and then we have a constant of 4. All of those are real numbers, so we're okay. The only thing that's a little bit iffy is that square root. Now, technically, square root isn't a coefficient. It's also not an exponent as it is, so we can't say that it doesn't meet some of our requirements right now. However, if we haven't seen it before, I'll tell you now. A square root can actually be rewritten as a fractional exponent. So square root of x can be rewritten as x to the 1/2. So notice that we have a 1/2 exponent. 1/2 is not a whole number, which means it's not an integer. So our answer is going to be no. Then on part C, we have we have real number coefficients 1, 2, and 6. However, we have -3 and -2 as our exponents, which are not positive, so our answer is going to be no. That's not a polynomial. Alright, next up we're actually getting into our operations of our polynomials. Whenever we are adding or subtracting, the big thing that we're going to do, or what we want to look for, is we are just going to be combining like terms. Now remember, a like term has to have exactly the same variable, which means that like x and xy are not like terms because I don't have a y in the first one. Likewise, x and x squared are not like terms because one of them has 2 x's and one of them only has 1. So just keep that in mind. So, on our first one, notice that we have a 4x squared and a 2x squared. We are subtracting, so we have 4x squared minus 2x squared, which would give us 2x squared. Next up, we want to look for our x's, so we have a -5x and a +3x, but again, be careful because we're subtracting, so we have -5x minus 3x, so we're going to get a -8x. And then lastly, we have a +6 and a -1. So we're saying 6 minus a -1, so it's going to become addition, so we're going to get a +7. Continuing in that same pattern, again, I have a 6x squared and a -4x squared. The only difference this time is that our operation in between the two is adding. So we're adding 6x squared to a -4x squared, which is going to give us a +2x squared. Next up, we have a -7x and a +9x. We're adding, so we have -7x plus 9x is going to give us a +2x. And then lastly, we have 8 and -5, which is going to give us a +3. We always want to make sure and check, do I have any other like terms that we can simplify? Neither one of those we do, and so both of those would be our final answer. All right, next up we're going to be looking at some multiplication. So notice on the inside of my parentheses I have a trinomial. On the outside I have a monomial. So remember, a trinomial means I have 3 terms. So I have 2x squared as my first term, negative 4x is my second term, and 6 is my third term. And then on the outside, a monomial means that I just have 1 term. I have 3x. And anytime that we just have a monomial times any type of nomial on the inside, we're just going to distribute. So we need to distribute that 3x to all 3 of the terms. So we would have 3 times 2 gives us 6. X times x squared is going to give us x to the third. Moving on, 3 times negative 4 is going to give us negative 12. X times x gives us x squared. And then 3 times 6 gives us 18, and then we still have an x. We want to check and make sure that we don't have any like terms that we can combine. We don't, and so that would be our final answer. All right, next up, looking at these two, notice that we have a trinomial, 3 terms, times a binomial, 2 terms, which makes this a little bit different. So we can't think of it like distributing. So what we're going to have to do is multiply everything in the first one by everything in the second one. In the past, when you've had a binomial times a binomial, you've probably heard this be called foiling. It's a similar process with this, but because we don't have just 2 terms in our first one, it's not quite the same as foiling. So I like to call this the rainbow method. So we're going to take n squared and we're going to multiply that to n and to the 2. So n times n gives us n cubed. N squared times 2 gives us a positive n squared. So then we got to move on to our second term. So I'm going to have 4n times n and 4n times 2. So 4n times n is going to give me 4n squared, and 4n times 2 is going to give me 8n. And then lastly, we move to that last one, our negative 6 times our n and our negative 6 times our 2. So you can kind of see why I call it the rainbow method, because we're kind of making little rainbow arcs up there at the top. So then we have negative 6n and a negative 12. Then we need to combine any like terms that we have. So notice that I have a 2n squared and a 4n squared that are the same. And then we have a 8n and a negative 6n that are the same. Our n cubed and the negative 12 are just kind of by themselves, so they're not going to change. But I have 2n squared plus 4n squared gives us 6n squared. And then we have 8n minus 6n gives us a positive 2n. And like I said, the negative 12 does not change. Again, we always want to make sure and check, can we combine any of our other like terms? No. Do I have any negative exponents? No. Nothing else can be simplified, so that would be our final answer. In our next video, we're going to talk about division. It's a little bit different than our addition, subtraction, and multiplication, so just be looking out for that.